So our presenter tonight is Curt Bolton from Huber Engineered Woods. He's going to talk to us about the zip system wall sheathing and roof sheathing. And with that, give it over to Curt.
Right on. I want to thank y'all for letting me come out. I've been in the industry. You were saying earlier, I believe, started in 1983.
Yes.
Born in 1982. You guys are going, hey, there's someone here. Is there anyone here who's hasn't been around? I got barely beats that out. So.
Almost.
Almost. What'd you say? Yeah. Way back when. So my parents grew up telling me you got to get A's in school. You're going to dig ditches for a living. You're going to end up, building stuff. And I got A's in school, but I got degrees in econ and got out of, finished my college matriculation process about the time everyone wanted to shoot The Economist about 16 years ago or 16, 17 years ago or so. So fell back on what I worked my way through school doing, which is building stuff. And I worked for builders and contractors. I've been in a couple different manufacturing companies. So and it's now where I want to be, right? I think there's a lot of great stuff about the building industry. I think one of the things that I think of in my career is people don't understand houses. Even the people that are building them a lot of times don't understand what they're doing really, or why things matter. And they definitely aren't building things the way that they could be built in order to make sure that they are, maximizing the long-term durability of that structure, right? And it's not just the stuff I've read, but I've seen dozens and dozens of stories of this is the cheapest thing you can legally buy. This thing costs 10% more and it'll last 3 times as long. And people buy the thing that's going to fail in 10 years all the time. So I try to work with companies, whether they're contractors or builders, to try and do things that are sort of a grade above that, sort of keeping an eye on the long-term durability. And that's the company I work for right now, Huber Engineered Woods. They're kind of a disruptive influence in the industry. They like to look at problems they see in the world, in the construction space. And they try and figure out how to solve those with good building science. So we've done a lot of partnering with people who are sort of the who's who of various segments. Most of what we do has to do with wood panels or things that are related to wood panels. But turns out there's a lot of stuff that touches wood panels in the house, right? We got our start as an organization, probably, there we go. Maybe a 40 to 50-year-old company at this point, HEW. But HEW is a smaller subsidiary of J.M. Huber Corp, which is a 140-year-old privately held company, right? Very old for America, very old company. Got started in the chemical space. We're big believers in ethical behavior. Everything we do is to solve a problem. Our first product we ever launched really as a wood company, it's called Advantech. It's a subfloor panel. It's OSB. But the problem you had with most wood panels at the time was that they were made with water-soluble resin. So during the construction process of a new structure, there's going to be water that sits on that house. Doesn't matter if you're Ryan Homes, you turn the house over in 83 days, or if you're some custom builder, lets it sit for 1.5 years between foundation and when you close, that panel is going to get some water on it. And the issue was that water, if it's a water-soluble glue, will rinse out of the board if you let it get wet for long enough or wet enough. So we said, there's got to be a better way to do this. We started putting basically hydrophobic resins in with wood. And turns out if you do that, you can get panels that can stay outside for long, long periods of time and still basically be structurally brand new. That's how we got our start. And everything we've done since then has been, this is a problem. Let's figure out how to solve it going forward. We believe in ethical behavior and trying to make the world a better place, mostly through the better products. We've got a bunch of mills. There's about to be another mill that opens down in Sugarlock, Mississippi, which is basically right on the border between Alabama and Mississippi, about halfway it's basically in the middle of those two states. Pretty much all the wood you'd ever get from us are going to come from one of 2 places. It's either going to come from, this pin's wrong, it's supposed to be here, but from Southern Virginia or out of Eastern Tennessee. Most of which you're going to get is going to come from there. But first mill is up in Eastern. We got one in Georgia. We also got one out in Oklahoma.
What town is the one in Southern Virginia?
It's in Crystal Hill, near Lynchburg. I mean, I say near, it's like 53 minutes from Lynchburg. So Zip System is sort of the next thing we launched after we launched Advantech. Zip System is a wood panel, structural sheathing, that that has a WRB built into it. So when you make an OSB panel, it's in a mill, they shave down logs and they make what basically looks like playground mulch, or what I think of as playground mulch. I haven't seen a playground with much mulch on it lately, usually it's plastic now, but when I was a kid, they had mulch. And it comes out as a mat, maybe 6 to 12 inches thick, mixed up with a whole bunch of resins, and it goes to this giant press. Goes into a press for maybe 4 or 5 minutes, comes out the other side, and it's a 1/2 inch thick board. It takes this mat that's about like that and turns it into something that's about that thick. When that happens, the bottom layer, when it's a zip panel, is this WRB layer. It's this paper product that has WRB capabilities, and it's thermally pressed in the stack press. And when it comes out the other end, it is extremely difficult to get it off of the wood. If you can rip off part of the zip WRB from the wood panel, it's going to take wood chips with it. It is as on there as the wood chips are to each other. So there's a bunch of benefits you can do to that. Most house wraps have like a 30 to 90 day exposure rating. It means it can't be out for too long because, you know, UV will break it down and it has to have certain capabilities. So it can fit on a roll and get up onto a ladder and be installed on a house. It doesn't have to worry about that. It has a backer on it. It's got this big wood beefy panel. So you can do things that might be a little more brittle if you were trying to put it on a roll. But since it's not on a roll, since it's backed by wood, it can be much more durable. You can have all these extra capabilities. Zip panels can stay exposed to the sun for basically half a year. That's sort of the normal amount of time. The zip system is WRB, but the panels have gaps, and those gaps have to be treated with tape. The tape is a similar exposure rating, 180 days exposure, no problem. We're a privately held company. Go for it, brother. By the way, interrupt whenever.
Tape. We oftentimes I'll see a zip system with Tyvek tape.
Yeah, that's a bad idea.
Yeah.
So there's 3 different species of tape.
Next slide.
There's 3 different species of tape. First species I used to see was asphalt. I used to be a roofing guy for a little while. There's asphalt tapes, there's butyl tapes, and then there's acrylic tapes. I used to think acrylic tapes were garbage. And the reason was because the only acrylic tape I was aware of at that particular point in my career was the house wrap tapes. Looks basically like packing tape. So you're gonna mail something to one of your cousins or kids for Christmas. The problem with that tape is it's only 0.8 mils of adhesive. So if you have an acrylic tape that has more adhesive, it'll stick better. Asphalt tape's off gas. They get warm. It doesn't matter whether they're covered or not. The fact that they get warm means they're going to off gas. And when they off gas, they start losing a lot of the capabilities that made them good tapes to begin with. And so if you've ever pulled out a window or done something on the roof where you're doing with an asphalt tape, after a certain amount of time, it's extremely brittle. You know, there's that whole, there are 2 kinds of windows, those that have leak and those that will leak. You know, this is part of that, is that you have this issue with tapes that are not long-term durable, even once they're covered. Butyl tapes are okay in some cases, but most butyl tapes aren't 100% butyl. They have other additives in there. When they have other additives, they still tend to off gas. Normal butyl can be long-term dimensionally stable. This is what I thought the gold standard of tape was for the longest time, with the butyl tape. When you get an acrylic tape, though, acrylic tape's weakest point is when it's first adhered to the board. When you put it on the board, that is the weakest it'll ever be. Whereas every other tape, you take a piece of tape, you pick it, you put it on there, and you pick it up, it's lost like almost all of its adhesion capability. If you try and put it back down, you're going to have major issues. Acrylic's not like that. You can move it around a little bit, you get some workability, but when it gets hot behind the cladding, it'll actually bake its way into the panels better. So tape that's been on there for 6 weeks, it's actually much stronger of a bond than when it was first applied. There's other things that you have to do to get a good bond, but just having it on there for a while will actually do a lot, especially in warm weather. Not so much in the winter, but when you get into the summer, it starts getting above 40, 50 degrees all the time. You get really good bond there. The thing that kills acrylic tape, which will kill any of these tapes really, is they're almost all, unless they have a lot of additional additives to the backer, they're all UV sensitive. Too much UV radiation, just exposure to sunlight, will break them down over time. And that's the same problem you have with every WRB. The UV exposure will break down the WRB if it's exposed. So there are stabilized things out there, tapes, flashings, products that can be exposed, that count as WRBs, but they are much less common and much more expensive. So when you first apply the tape, people tend to just smooth it on with their hands. You get about 40% of the bonding adhesion from that you're going to get. If you want to increase it, the best thing you could possibly do is roll it, right? People think they just roll it on there and they'll push it on, and they're a mason, and they're a carpenter, or there's somebody, and they've been working for 40 years and their hands are hard. It doesn't matter. Your hands have fat, your hands have flesh. You ever try and press out cookie dough with your hands? I don't know if anyone's ever baked cookies or baked cookies with somebody, you know, with kids, wife, spouse, you know, whoever. You try pressing out, you get really uneven results. You take a rolling pin, even without a whole lot of pressure, you can get it to sit much more evenly. And the reason for that is that your hand yields. It's not consistent. It's got fat, it's got flesh, it's not all bone. So if you look at a panel, or really any surface underneath a microscope, what you'll see is that it is not flat at all. It's got all these ups and downs. And what you're trying to do is you're trying to take all of this adhesive in here. This tape is about 2/3 adhesive. It's 12 millimeters, 12 mils thick. 8 of those mils are adhesive. It's 10 times the amount of adhesive that'd be in a roughly equivalent house wrap tape, Tyvek, Typar, things of that general category. What you're trying to do is you're trying to push all this adhesive into all those little nooks and crannies, like an English muffin. You're just trying to get it all in there. And if you just push it on with your hand, you're not going to get that. And so you roll it, and even with a relatively moderate amount of pressure, about the same amount that would be necessary to paint a wall, you can get a lot of those nooks and crannies filled in. Now, that being said, you add a little extra time to that mix, and it'll work its way even more because it'll heat up and the adhesive will flow. But if you don't start pushing it in to begin with, if you don't begin that wetting process with a rigid surface, one of those rigid rubber rollers, it won't begin. And you don't have to use proprietary rubber rollers. There are lots of rigid rubber rollers out there for various, you know, different scopes in the building industry. There's no reason you couldn't use one of the ones that's used for welding rubber roof membranes or other things like that. So the taping is important. Rolling the tape is the most critical part. You get all the other details wrong, but you roll the tape, you're probably in pretty decent shape. So what we're going to do here is I'm going to run through real quick. This is our commercial installation pre-con. We go through this with people when they're about to build an apartment complex. And the main idea behind this presentation is we're going to talk about all the details that could be out there, all the sort of areas where you might have a trouble spot, so you can talk through those details. And then I got a little quick presentation afterwards that say, if this is going wrong, this is what you do, kind of thing. So we'll go through that. All wood panels are supposed to be gapped. These are wood panels. There's nothing particularly special about them. They're a little stronger. They're called a struck one panel. So they're stronger than a typical panel that you would get in the industry. They have biggest difference really is if you push on the panel in between two of those studs, it's going to bow less. It's more rigid. It has slightly better resistance to racking. So you do get some values, but this isn't a high seismic load unless you're building in a couple key areas or out near the ocean in this general area. That wind loading isn't even that big of an issue. So mostly just remember, treat it like it's a regular wood panel, you'll be fine. It's stronger than that, it can handle more than that, but just treating it like a regular wood panel will be okay. And almost all this stuff around gapping is code-based. So our nailing requirements are taken straight out of the code book. It's a 16 nail. You know, you're looking at a 612 nailing pattern. You might need something that's more than this if the architect or engineer said you needed it, but in general, this is perfectly fine. Pretty much any residential structure that you're looking at, anything that's a townhome, single family, this is almost certainly going to be adequate for those needs. The biggest complaint we hear about, the biggest headache from inspectors and from code officials and from people who work for, you know, going out and actually doing the code inspections on houses for whatever municipality they're in, is overdriven fasteners. Okay, with our system. So this is the logic behind this complaint. Your WRB is here, your wood panels here, your studs here, right? If that fastener penetrates through the WRB at all, even a little bit, it's going to cause issues, right? You're going to get moisture into the envelope. There's going to be all sorts of problems. That nail needs to sit at best flush or on the surface. This is the logic that is there to protect the WRB. It turns out It's nonsense. If you do any real testing around it, the amount of pressure you'd have to put on this nail head right here would be the equivalent of like having 20 feet underwater. And if you do that, or if you have I forget what it was, like a 20 inches of rain per hour and a 230-mile-an-hour wind on an unexposed surface will also cause that to leak. It turns out that's the case, you have much larger problems. So it's not real world tests. You can make anything fail, but the level of this stuff fails at is really, really high. So in a real world application, we pay out anytime there's an insurance problem. People look at our panels, there's some kind of failure with its floor, wall, whatever, and people are concerned about its performance. We almost always just write a check. We aren't legally required to. I'm not going to say we should do it. We probably shouldn't write some of the checks that we write, but we do. We want to take care of people. We believe in our product. We stand behind it. We have never, in the entire time this product has been available in market, written a claim on an overdriven fastener, ever.
So Curt, we got a question here from the online audience. He's asking, do you recommend installing it horizontally or vertically?
It's a great question. The short answer is it doesn't matter. The most common application I see is where there's actually a combination of vertical and horizontal. On a wall, you'll have verticals for the majority of the wall, but over the plates, the floor assemblies, they'll install a horizontal panel. That installation will typically bridge the bottom of the upper wall and the top of the lower wall. And when you tie those together, you don't always need the same kind of strapping. It's a good detail. The only way it's going to matter really from like a structural value perspective, you're not really going to get any real benefit from a racking resistance or wind loading or seismic. The biggest benefit you're going to get is if you try pushing in between two of the panels, in between two of the studs on the panel. If the panel was oriented horizontally, you'd have very slightly better resistance. It'd be a little stiffer going that direction. But since that's not really a very large concern for most people, it's something that doesn't happen very often. There's a lot of pressure pushed that way in a way that would matter to the durability of the cladding or the durability of the structure. It turns out not to matter almost at all. But that's the only way it matters even a little bit. Great question. So two things will happen if you overdrive it faster. The first is you could potentially have some moisture intrusion, right? Anytime you have a penetration through there, water could sit and cool here for a little bit, theoretically, a small amount of water, standing water sitting against there for a variety of reasons. It's really unlikely that that'll cause a problem. But the second thing that will cause a problem, the second thing we look for is you've lost the structural holding power of that fastener. By the time a fastener is about halfway through a panel, it has lost over 80% of its holding power. So when you think about like how well it's going to resist to racking, it's lost 80% of its power. Which means if any load is applied to it, it'll pop through the panel or it'll separate from it in some way.
So we got another question. To follow up on the earlier one, do you recommend taping over the overdriven nail? Well, I guess you kind of addressed that.
If it is overdriven, like truly overdriven, yeah, it'd be good to recommend. The thing is that when we draw the line, we start drawing the line for overdriven is about halfway through the panel. The rule of thumb that we'll give the installers, if you're walking around, you're like, hey, is this wall completely messed up? Start looking to see if you can clearly see the nail head. Or if we're pretty good judge of distance. If you can tell the nail is more than halfway through, that's an area where you should start thinking about it. But again, the first thing that's going to be a problem is it's losing structural holding capability. Now, it's a 6 and 12 nailing pattern. They're nailing 3 and 6, and they miss a couple of these overdriven wides. It's probably not a huge issue. Again, maybe check with the engineer, check with the architect, make sure that's going to be okay. But the first and larger issue is that nail is not doing its job at holding the panel of the wall anymore. That being said, once it starts getting completely overdriven, you do have a concern. Our concern for an actually overdriven fastener, something that's more than halfway through the panel, would be to tape over it or use one of our fluid applied systems. Great question. When people are installing tape, almost all these details are going to be tape, by the way. You're going to get sick of looking at tape. But there's two kinds of joints where you could have tape coming together. Any kind of T-joint, you want a 1-inch overlap. The easiest way to think about this is there's a seam behind here, right? So running this way like this, and there's a seam right here. When you take this, the vertical of that T, just stop it at the seam and run this across. There's plenty of slop in there, but the rule is you need at least 1 inch. 3 inches. If it's end to end, best way to think about this is a slightly over 3-inch tape is 3 3/4. make a square, just make it about a square. So visually, when you're looking at it, it's about a square when you're sticking the tape up and then running it along. You'll be fine. Again, this roll of tape is gonna be on everything because it's the most important part. If you don't roll the tape, you're likely gonna have issues that you would not have otherwise. And if you do a lot of other things wrong, but you roll the tape, there's a pretty decent chance it won't actually materialize into a real issue. This right here is the worst taped thing on any wall. Any wall you walk out, you want to know whether the guy or gal or whoever's installing that tape knew what they were doing when they did it. You'll look at that corner and you'll see how well it's done. It'll be tight to the corner. There won't be a lot of wrinkles. One of the things that'll tell you they really understood what was going on, they probably were trained by someone at one point, is it won't just be one long piece running top to bottom. Turns out that's really, really difficult to do on an inside corner. They'll do it in about half wingspan lengths, 2 to 3 feet. You see a bunch of 2 to 3 foot sections that are shingle lap. They start at the bottom and work their way up the wall, and it's nice and tight into that corner without a lot of wrinkles. That taping crew knew what they were doing. I'm not saying you back off, but just know that that's what that means. You see this is a really good indicator. You want to save yourself some time, start there. Just go find an inside corner and see how well they did with it. Outside corners is much easier. You just tape down one side and then fold it over onto the side. One thing you'll see with this, and this started to become more relevant as the energy codes are changing, continuous installations becoming more prevalent, especially in DC. And you know, some of the higher end communities around here. We have a product where it's the zip panel and it has a polyiso insulation panel on the back of it. So it's installed as one panel that gives you your continuous installation. The biggest issue with these outside corners, and they start using continuous insulation, is if you butt 2 panels together, you start having this void that's not a nail base, right? That polyiso foam is relatively rigid if you push against it, but it's not something you can nail into. Nails just pull right out.
So what do you call that material?
It's a continuous insulation panel.
Okay.
It's a zip R, our sheathing, our value. So zip R. So that's the biggest issue we're doing outside. Outside corners are relatively easy to do. You can tape you can tape a 40-foot corner with one piece of tape if you wanted to, and the person had a ladder and they're willing to do it. They'll take one side and they'll come down the other, but in general, not a huge area for concern. Just like the regular seams. So you start having penetrations, anything bigger than the rule of thumb we have for what we call flesh wounds here. So you have like a cut in the panel, and you can't cover with a quarter or your thumbnail, you should tape it. When you can see the wood through the green, even if it doesn't go all the way through, you should tape it. Sometimes that's someone got a little overzealous with a compressor and they put a bunch of nails in one area and they managed to like break off a flake of wood in between them. Maybe someone used it as a sawhorse and put a big old gouge through it. Maybe someone got a forklift and punched a little hole through it. If you start getting less than 2 inches diameter, you know, you can just repair it with tape. Once you start getting bigger than that, it's time to start removing a section, blocking, and installing a whole new piece. Our rule is basically if you can't put your fist through it, or sorry, if you can put your fist through it, and you can't put your fist through, you probably can just, you know, tape over. Anything bigger than that, you're going to start needing to cut out a section and retape it in. So one of the worst case as we see for this is up in the top of gables, and they build a house. They'll install the panels on the ground on the end truss, right? They will then punch a hole through it, like with a hammer or with their fist or headbutt or whatever. And then they'll put a chain through it, crane it up, install it normally, and it'll all be taped already, right? So they don't got to go up there with tape to fix anything because it was all taped on the ground. It's a great idea, by the way. But then they get up to the top and there's this hole that just sits up there. Now you start talking about like, well, it's technically in an unconditioned area. It's into the attic. Are we worried about the air? Are we worried about, there's all these sort of like what ifs. Don't do it that way. Have them cut the top section out, remove it, tack it right below where it's going to go back in, just cut it. And then when they put on the roof sheet and the guy just leans over, he's already tied in, he's already up there installing it, leans in, pops the thing off, puts it where it's supposed to go, nails it, takes off the tape, puts it down, rolls it, and walks away from it. He's already up there. It's already easy. He doesn't want to bring a saw up with him, so just cut it when it's on the ground, tack it right next to it, be super easy. Again, you see a detail like that, that means that crew's done this before. That means they've thought about it. They've, you know, they've really, and they also care, not just they've done it, they care to get it correct. Yeah, this is one of the bugaboos of the industry. Is there's not really an official code requirement on how you treat this area on any wall, right? What do you do when the wood comes down and meets the masonry? Mostly around here, it's like basements, not so much crawl spaces. There's some, but you get on the shore, you'll get more of those like pier-based systems. But right here, there's a bunch of things you can do. Best thing, really, liquid flash, fluid applied system. Cover that joint. Tape's not really going to adhere to the masonry very well. It will if it's dry and clean and free of debris. That's no concrete I've ever looked at on a job site would meet any of those requirements, let alone all at the same time. So you can do a couple things. You can do a kick out flashing detail there, which is what they have shown. That will keep any water that's running down the wall and kick it out so it doesn't get the potential to get caught in between the bottom of the panel and top of the wall. It sits there for a while, corrodes, all that kind of fun stuff. You covered over with the fluid applied stuff. Fluid applied will stick to brick and masonry just fine. It'll stick to you just fine. So be aware if you use the stuff, it's messy. You're gonna have a gray splotch if you get it on your arm for at least like 2 weeks. But the other thing that you're getting when you use the fluid applied is it's helping with your air barrier. It's been code for a while to have some kind of capillary break here. The sill seal, it's a foam-based product almost everyone uses. The issue is you install this, people what may glue one side of it, they don't glue both almost ever. And so there's, if you think about joints, where all the joints are, there's a joint here, there's a joint here, there's a joint here. And if you had a sill seal in between the two, there's a joint between the wood and the sill seal, and a joint between the sill seal and the top of the masonry. And odds are one of those two is not going to be perfect, and that's an air infiltration. You have to meet 3 air changes per hour, which is what current Maryland code says. You're chasing things you could fit a credit card through. You have 16 unfinished nail holes in that entire typical single family home. You've gone from 3 air changes per hour to 4 air changes per hour. Is a big difference. But chasing little gaps like that run the entire perimeter of a structure is a big deal. If they put a sealant down below the sill seal and on top of the sill seal, it will keep it relatively airtight. If they don't, you could spray foam behind here. That will also help solve that problem. Or you could put a WRB compatible flashing that also breaks up the air movement, which is what the fluid applied is. So there's a lot of ways to skin that cat. I'm going to flip through these because it's a lot of the same stuff. There's basically 3 kinds of things you can use to tape a mechanical or a physical penetration, like a beam or a pipe or a wire or an HVAC or a vent, an HVAC conduit or vent. You can use a regular seam tape if it's flanged. It's a non-flexible material, just 1, maybe 2 planes, like an outside corner, inside corner. You can use stretch tape, which you can bend any way you want. You can stretch it to 2.5 times its original size. You can use one of those kinds of products, or you can use one of the fluid applied systems. Any will work. They're all pretty compatible. It's mostly just understanding how to do it correctly. This is a reasonably well done joint. Comes out of the wall. You need 1 inch onto any surface in order for it to be a good bond. It's a good rule of thumb, and it applies to almost all our products. In this instance, they're going to use a seam tape because that is a flanged box. You don't want to use seam tape if it's a round opening or an unusually shaped opening. It's just not going to work really well. The biggest difference visually, if you're walking behind someone trying to figure it out, if it's a big enough piece, it actually says stretch tape on it. So that's a really good indicator that it's stretch tape. The other side of it is stretch tape is sort of translucent. It's black on a roll. Looking at it, you're like, oh, black. They're the same thing. The stretch tape is much thicker, like 3 times thicker than the regular seam tape. So there's a little bit of that, because there's usually seam tape you can see somewhere nearby, and you can tell whether this is thicker. And the other thing is it's got this sort of translucent quality. You can kind of see through it a little bit better than you can with the regular seam tape. So with this kind of thing, with a flange, again, to the extent that you can, it's always a good idea to shingle out things. So bottom, sides, and then top. And then that's it. You're good. We went too far away, maybe too far away. Yeah, I don't like this detail. It's in here because they use a lot of these on commercial construction where they have water tables and other masonry, the directly adhered masonry on the bottom. They're using regular seam tape to tape in a box that is flanged, but it's a flange that sticks away from the wall. This is not a great detail. It works. You can absolutely do it like this. You better know what you're doing and you better adhere to it well, because you're gonna have to actually slit the tape in various places in order to get it to sit flat. Anytime people start doing that, I start getting real skeptical that it's gonna get done correctly. So again, it's flanged. This is a perfect application for using the seam tape. I'm gonna try and put these a little faster. Just so I can slow down a little bit here. Very similar detail to what we looked at a moment ago. Tape it in. This is a real world application for that. This is if you have a bead that goes through. This is a stretch tape. It's a lighter color in this. It's how we show in the slide. That's what it is. This stuff is really easy to install on weird shapes like this. You take the tape, it's got a backer on it. You can peel the backer off. You fold the tape over so it's non-sticky side, like make it thinner. Drape it over whatever it is and start working it on the main wall, and it's really easy to get right. If you see it's not a stretch tape, it's much more likely that it was installed in a way that it was like good for the wall. This is what that looks like. Transitions, like I said, our tape's great. It's sticking to wood, it'll stick to plastic, it'll stick to metal, it'll stick to other wood, WRBs, all sorts of things you can integrate it with, right? It'll attach to their house wrap products. If you have to integrate like an addition or something, and there's house wrap on one part and zip on the other half, you can tape to house wraps and it's fine. It's the same kind of adhesive most house wraps use. This is an area where you are not going to get a good bottle tape. Any kind of masonry, not going to go super well. You're going to want to use a fluid applied in this instance. So what that looks like is you're going to have some kind of gap because there's code required that you can't have non-pressure treated wood in direct contact with a masonry product. They will just trade moisture back and forth to each other. The masonry will be okay. The wood product will not be eventually. It'll eventually rot. So you leave a gap. Our fluid applied stuff is a very, very, very expensive gap filler. Much easier to just stick in backer rod and cover over it with fluid applied. But fluid applied is definitely the joint treatment of choice when it comes to masonry and wood joints.
And how is that applied? Is it brushed on? Is it like caulk gun?
Great question. It comes in caulk tubes, so big caulk tubes, little caulk tubes, and sausage tubes. It comes in all those versions. You caulk it out. It's basically the consistency of peanut butter, and just like peanut butter, it's different consistencies outside in December and in August, right? So it's going to come out, and then you sort of tool it into place. Don't use your finger. Use a plastic putty knife. Use a plastic spreader. You can also just take a bristle brush, cut it really thin back. For the kind of inside corners we were just looking at. You could take a water bottle, like one of those, like a Deer Park water bottle that you find on any job site in North America, and you can just take that and use that as a tool to run it down outside. You can take a spoon out of the roach coach that you were having your lunch with, rinse it off, and then you could use it on there. It'll also do a really good job at it. Doesn't have to be anything fancy. There are things you can do that'll definitely work well, that are actual tools designed for it, but really you're just trying to smear it out a little bit. The way that you know that it's on thick enough is you can't see through it. It's a dark gray color. If you can't see the green through it, or you can't see the wood through it, or the whatever it's over, then it's on thick enough. And it'll stick to everything. I mean, like I said, it'll stick to you if you get it on you. The one downside with this is it's like a moisture curing product. So that's great if it's like raining. Oh, there's a leak. I need to fix this leak. I know where the leak is. I can see it right here. You don't have to worry about coming back when it's dry, because the tape ain't gonna stick if it's wet. The tape needs to be dry. The surface of the tape has to be dry. This stuff, go for it. Put it on there. The water will actually help it cure faster. The downside of that is that the moisture is necessary for curing. And so in January, when the high temperature is 33 that day, there's not enough moisture in the air to allow it to cure effectively. You install this in April, it'll be cured in 6, 7, 8 hours, maybe fully. Definitely the next day when you come back, it's good to go. But you install this in January, it might be on there too long to really have a good cure process. But, you know, the way the weather's been going lately, there's definitely going to be a week where it's above 40. You get a couple days where it's above 40 in a row, it's okay to install this stuff. That's what we recommend is ambient air temperature over 40 that day, and you're gonna be all right. Anytime you have a flashing on zip, there's all these sort of, you think like a through wall detail where you like cut through the house wrap and then you would slide a flashing in and tape it back in, right? Any of those kind of details, whether it's windows or water tables or apron flashing or step flashing, you know, anything you would have done with that. Anytime flashing goes back to zip, just take a piece of zip tape, tape over the uphill end of that flashing, and it is now a through wall flashing. So that's how you get to be. So you can put anything back there. You can stick with the this, what we have here is just like a water table, top of the masonry kind of flashing. You do this with the step flashing. This is the most common place to see someone use a non-zip tape, by the way. So if you're gonna look at a wall and it's gonna have a bunch of zip tape on it, windows are zip tape, the zip is zip tape. The place that is the most likely to not have zip tape is the flashings along the roof line.
Well, that's because the roofer did it.
That's because the roofer did it, because it's a different installer. And that's one of the issues we see with new zip builders is they will not have talked through all the people, because you don't think about how many people are going to touch an envelope until you're actually doing it, right? Because the framer comes up and he's touching the envelope because he's installing the structure, which is part of the envelope. But also the WRB, he's taping that in. Then you got the window installer, might be the same guy as the framer, but not necessarily. Then you're gonna have the mason, he's probably not the framer at all. The siding guy is probably different than the framer. The roofer is definitely different. HVAC, electrical, plumbing, all these people, maybe even a deck guy or railing people come up. All these people are gonna touch this in some regard, and understanding and having the GC or the project super or whoever have a conversation with all of those different trades. Hey, when you put a hole through this, it's your responsibility to handle it. I'll help teach you, but you need to fix it. That's something that a lot of new guys don't do. And then we come back out and we call it an observation where we show up and there's stuff that's wrong. And then you got to correct it. And that's normal. You know, we're used to walking builders through that, but it's much better if we can get it on ahead of time with the builder and the framer to walk through something like this. The odds that it's going to be a correct install go up dramatically. Again, just another through wall flashing detail. This one over like decks. This is how I got started in the industry, building decks. So I'm very familiar with like the 8 little pickout flashes being installed there. You're gonna have a poured in concrete porch. Really good idea that whatever Vicor or felt paper you're using to separate that masonry from the wood that's behind it, tape the uphill end. Otherwise, any water that gets behind that is just gonna sit there forever. You're gonna completely defeat the purpose of having that vapor barrier or water barrier. Parapet detail is not super common in residential. It's more common than it used to be. You know, flat roofs are the most likely to leak of any roof type that I've ever come across. I used to be a roofing guy. Getting this parapet detail right is belts and suspenders and cummerbund and like, you know, sewing the pants to the shirt kind of deal. So you have like a whole bunch of redundant things that would all have to fail simultaneously to get water to infiltrate going in there. Because if it does get in there, it's really, really, really bad. It's just going to completely destroy that entire wall. So you'll start off by making sure that you tape the zip all the way around, put a piece of tape on top. We make pieces of tape that are 12 inches wide. Most walls are not 12 inches wide. So you can effectively cover over the top of a parapet with zip tape. And then it's usually a good idea to put some kind of, you know, physical positive slope there. Usually, you know, lap the roofing membrane over the top of it. And then it's a really good idea to have some kind of like metal cap detail over the top of all of it. A number of things would have to fail for that to go wrong. You can be more confident in it, but it's one of those areas that if we see a parapet detail on something, we really hone in on that because there's a lot of things that can go wrong there. When it comes to zip window installation, really, these are the window installers details. We just have our version with our tapes on it, right? So we use our stretch tape to fill in the sill. You want it to go up at least 6 inches up on a side. Every once in a while, you'll see that they cut a piece that was long enough, but it's lopsided. It's 2 inches above the sill on one side, and it's, you know, 10 inches above on the other. But the good news is you could just take a piece of tape and extend it further up, and that's completely fine. So there's a lot of easy ways around that. But then roll the tape, most windows are gonna require some kind of sealant behind it. This is for a flange window. You don't tape the bottom of it. You want to allow enough of a gap that if any hydrostatic pressure develops behind there, because there's actually water in the window system, that it can drain out the bottom. And this is a window installer guideline. This isn't just us. We just know what their details are. We include it in our installation instructions. So we do deep dives about every, I don't know, 5-10 years on our products. And we like to look and say, okay, we love it. It's great. Everybody thinks it's awesome, but what's the but? You always want to know what the but is. You know, Curt's a great guy, but he tends to talk too long. So the thing that was the but when we first looked at Zip was 90% of leaks were right here. It didn't leak all the time. If this was done the wrong way, it wasn't necessarily going to leak. But if it was going to leak, this is where it was going to leak, like the majority of the time. And this is a reverse shingle lap window header. We don't have any requirements really for shingle lapping correctly on the rest of the wall. This area, we have very, very strong guidance. It's in our best practices. It's in our installation requirements. So this is the way a normal structure would be taped in. The framer comes in, he installs a zip, he tapes all the joints, right? Then it's the WRB's in and he walks. And then the windows take about 6 years to show up. You know, because window installation manufacturing takes a long time. And so the windows get installed realistically several weeks later. All right, so what's happened is this joint has gone through a month's worth of diurnal pressures. It's expanding, contracted, expanding, contracted, expanding, contracted, expanding, contracted. And this tape joint right here now has a crease in the middle of it. That crease is fine. There's nothing wrong with that crease. It doesn't cause any problems with zip in general. But it does kind of create like a little mound right here in the middle. And when you tape the header tape over the top of that, you look down at it, unless you really were good at rolling it, there's going to be a little weep hole on either side of that. So how do you fix that? You come back and you just add more tape. There's a bunch of options for it. You could shingle lap it correctly to begin with and just leave those tape joints vacant, you know, while it was gone. You could install a double layer of the 4-inch flashing tape. You can come, this is the most popular, by the way, was that hat flash I just skipped right by, the one that everyone uses. This is the most common one. They'll just put a little piece right there, and that's fine. You can use a 6-inch piece of tape. That's also fine. Like I said, we make a bunch of different thicknesses of tape or widths of tape. Using a 6-inch tape is fine. But yeah, those are the main ones. Also, most window headers, they're going to have any kind of dimensional trim. They're going to have a kick-out flash like that and tape the uphill side of it. When you start moving over towards flangeless window installations or flangeless door installations, it becomes much more critical, that top flashing detail. So this is a non-flange door installation. Be very similar if it were a window. First thing you do, well, if this were a window, you tape in the sill, just like it was a flange window. Then you're going to tape the jamb. Because what you're relying on here really is that all your caulking details and trim boards are going to be able to keep any moisture from getting between the window or door and the jamb. Long-term, 50, 100 years, you know, life cycle of a structure, odds that's going to hold up forever, not great. So you take the jamb, and what that does when water does get in, doesn't cause as much of a problem with being protected. Then you do the same thing with the header. Then when you install your door or window, you're going to go ahead and tape from the zip over onto the surface of the door, on like little jams. You're going to cover this over with the brick mold or the dimensional trim or whatever eventually, but it adds another layer of protection. You're installing all those boards. Now, this is the most critical part.
Well, the brick mold comes applied to the door, it comes already installed.
Yeah, so you're going to pull it off.
You
and
take
do
the
this
brick mold
with that.
off. Okay.
Yeah, take the brick mold off. Yeah. This is the most critical part. This is here's this kick out flashing over the top. Most of the moisture that's going to hit this is going to come from above, right? Most of it. Especially something that's going to get behind the bowl, it's going to come down from above it. If you have a kick out flashing that's extending, you know, if it's doing its job and you're using like a 5/4 by 4 trim board around the outside of it, I mean, you're going to be, you know, 6 inches on either side of the window or door probably. That kick out flashing is going to catch all of that water and kick it out over the surface, or the vast majority of it. That's what you're worried about, the bulk of the water. You take the uphill side, you're good to go. We would ask people if they were going to do a job and they wanted us to come out, how often do you want us out? Having a pre-con meeting is great because it helps you figure out issues that you didn't know you were gonna have with all these different details. We talked through them. But we should come out and take a look if you're gonna do window tests, if you're gonna do any other kind of moisture testing on the envelope. Also, I would tell people if we're gonna come out one time, and that's it, just once, the best time to have us come out is after the majority of windows and doors are installed. Because at that point, most of your mechanicals are through the walls, not all of them, but enough to know whether or not you're doing things correctly. Doors and windows are where most installation errors are occurred, and that would be when it would come out, because we have a checklist. It's available on our website. We hand it out whenever we do installations, trainings. It's these things. It's like 25. There's another 4 if you're using Zip R product. There's another 4 that you have to worry about for the installation products. But it's this whole thing. There's one thing that's on here twice. Anyone want to guess what that thing that's on here twice is? Roll the tape. There's 25 things. It's really 24 things to roll the tape. Because if you do that, it covers most of the other sins. All right, so this is the general installation that we do. By the way, if anyone wants to take a picture, I'm out of business cards right now. This is my contact information. For those of you who are listening, you get a pencil ready. It's 240-899-4208. It's curtis.bolton@huber.com. You can also just go to huberwood.com. If you don't live in Maryland, or you don't live in Delaware or DC, you have a local rep. You can always find out who they are. We are, our information is widely available. I'm pretty sure that's how Alan found me.
Yeah.
Yeah, so, okay. So it does work. That website's actually reasonably well maintained. But yeah, feel free to reach out. I live in Frederick. I cover DC. I cover out to Ocean City. I think out to Cumberland, Maryland is really about as far west I ever really go. There's lots of good reps in the area. There's a guy in Richmond, covers most of Virginia. The guy in Philly covers eastern half of Pennsylvania and Jersey. There's a guy in Pittsburgh who covers west. They're all fantastic. They've all been around for a while. They all know what they're doing. Okay, so the next thing I wanted to run through with y'all real quick is a bunch of, if you see this, do that kind of things. All right. We don't like seeing wood tight to concrete. It's going to have a problem eventually. It's really just a matter of time and how long that time is. There's a bunch of things that will affect that time frame, but in general, it's not great. We like to see a gap. Doesn't have to be a gap. You can also put a capillary break in. If there were a piece of aluminum flashing that was 0.19 inches thick or 0.019 inches thick in between these two things, not anywhere close to half an inch gap, it would still be okay. If that sill seal stuck out between the zip and the concrete, you're okay. Zip straight down to concrete, not great. Okay. All right. Next thing, when we see gaps, that's one thing we'll see. We say gapping is important. Wood moves, right? It heats, it expands, it cools, it contracts, it gets wet, it moves a little bit as well. Anything up to a ½ inch is fine. Walk away from it. If you can't quite get your carpenter's pencil in thin ways into it, you don't got to worry about it. It's good the way it was. You can just go ahead and tape it. If you can take your carpenter pencil in widthways and wiggle it, it needs something, and it'll need probably just foam. You can put baccarat in there, cut up a little sill seal, put in there. You can even spray in gap filler and then just trim it back if you wanted to. Up to an inch. So if you can turn your carpenter pencil all the way over and then wiggle it back and forth that way too, then you got to put something in there that's actually dimensional. What you're worried about is you're worried about there being enough of a lever on when that pressure change behind that tape to cause it to wiggle enough to actually break the seal against the wood and cause a potential leak issue long term. That's what you're worried about. The biggest places we see gaps, if it was a panelized house, meaning that the wall sections were assembled somewhere else, shipped to the job site and stuck together. This is something that Ryan does, it's something Cole does, it's something that like a bunch of builders do, especially larger track builders, but even custom builders will do panelization and have it shipped to the job site. And at the joints of those panels is very common because the foundation tolerances are crazy for how far out you can be. I mean, inches on a normal house, 3-4 inches, it's like, okay. So when they panelize stuff and they ship it out, inevitably there's some wall that's not quite wide enough to keep cheating it. And I could see gaps on houses I could stick my iPhone through easily, all the way through the wall, not just through the sheeting. Those things are going to need to be covered with some kind of gap. The other place you'll see it is exactly where it's shown, which is at the bottom of the gable. is people will stop it a little bit below the bottom of the truss, and they'll stop the panel that's on the truss just below the bottom of the truss, and you'll end up with an inch, 2 inch, I've seen 3 inch gaps up there before. If you just put them close to each other, it'll be fine. You know, if you just put the panels down tight to the plate and almost to the top of the other plate, it really doesn't provide an issue. So this is it's a very typical place to see it, but people are able to get around that pretty easily.
So what's the build? How do they build like that?
That's a great question. Just rip a piece of zip. It could be anything. I mean, you could with any wood, any structural product. It's going to be covered up with tape anyway, so it doesn't have to be zip. It could be, you know, 2x4 piece that you rip down for it. But most common is zip. If it's already the same thickness, you don't got to worry about it. You can just worry about filling the gap. Up to 1 inch, this is a good filler. Is doing the gap. Bigger than that, you're going to want to rip and put in a piece of zip. We just talked about anything up to over 1 inch. Yeah, one of the things with people will mess up when they're doing taping sometimes, it just won't be dry or it won't be clean. There'll be a lot of dust and dirt in the job site. Any of this dust or dirt you see down here, it's going to interfere with bonding. Other thing is, it's a non-pressure treated product. Code requires at least a 6-inch gap everywhere. I think it's actually more in most places. At least a 6-inch gap between non-pressure treated wood and grade. So people have, you know, flower bed. What is it?
It's 8.
Yeah, I believe it's actually 8 or more in most places, but I think nationally there might be some places that were 6.
Yeah,
But
good
you
luck.
may be right, maybe 8 everywhere.
Good luck with that.
Yeah. Just saying, it's one of those things you'll see issues with, and it'll especially be an issue during the construction process because it'll get wet and water will come off the top of the structure, be hitting right there, and it'll splash mud up onto the bottom of the panels. Even if no one's stepping on it or kicking at it, it'll still get dirty in that bottom section just because of rain and gravity.
Can you go back to that outside corner detail? Go back. Right there.
Right here. Oh, yeah. So, I don't see it here very often. I believe, Virginia, the guy in Virginia complains about this a lot more than I do. One of the things people will do is when they're installing panels, they'll keep the back corners of the panel. They'll touch those to the corner. Then you end up with this gap, right? It's basically a 1/2 inch by 1/2 inch void. And so when you tape over that, there's this gap behind there. And if it's perfectly tight together in the corner, it's okay, because it's a 1/2 inch, right? It's a 1/2 inch void. It's technically under the line. If you can see the stud, it's too big. You got to put something in there. I would highly recommend overlapping this panel onto that one, or vice versa. Right? Just overlap the panel. I realize framing doesn't always make that super practical, just with stud spacings being what they are. But it is definitely the best practice to overlap that panel onto the other one. It's not required, but the panel should at least be touching each other in order for that to be good. This is a much bigger issue on our sheathing because you have foam on the back of it. So those panels are much thicker. This panel is not even a 1/2 inch thick. The R sheeting panel is most common in this area is an R6. It's an inch of foam and then the wood product. So if you just touch the butts of those two things together, the back sides of them, I mean, you got a hypotenuse that's with a triangle, isosceles triangle. It's, you know, a 1/2 inch on a side or 1.5 inches on a side. That's a pretty big gap there. What we recommend there, you can just overlap them like a T, basically like an L joint. The other thing you can do is you can rip out 1.5 inches of foam off of one panel and just slide it over so you have wood all the way around. Doesn't really affect the insulation capability of the structure because all you're really doing is removing that last little bit that was out in the corner anyways. But yeah, this corner detail, I don't see this being a huge problem in most places, but it is a problem if it is there. It's not super common anymore. Great question. Another issue we see, I see this one all the time. This is a super common issue I run into, is when we're nailing, people, especially inspectors, not you all, but county inspectors, will complain all the time about overdriven fasteners. This is absolutely a bigger issue than overdriven fasteners from a moisture management perspective on most structures. When they're nailing in, especially if they're having to toe nail in to hit a stud, those nails aren't sitting flat, they're actually canted out at an angle, and there's a pretty good chance that some of the nail heads are sticking past the surface of the green. They're not flush, they're actually proud. And when they're proud, if it's in the middle of the panel, it does not really matter. But if they're on a seam, you're gonna tape that seam, because you need to tape that seam in order for it to, be code compliant for being a WRP. And when those little things are sticking up, it's like having a whole bunch of little tent poles underneath the tarp that you're putting down. Every single one of those fasteners has a zone around it where there's no adhesion to the panel underneath it. And if those zones get big enough, they'll just prevent the tape from bonding in general. And so that means instead of having a potential where a fastener is slightly over halfway in, where you have to get a crazy amount of air pressure and driven rain in order to get that fastener to leak. Anytime water gets behind that, if it was running down that were a horizontal joint and that tape had failed, you will have water in your structure. So when we're coaching people through on how to, deal with this, we'll talk about it in our first meeting. But this is one of these things that almost every job site with a new installer, we have to walk through. We'll tell them when you're taping, take your hammer, run it along the panel, so you can start hearing click, 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 click. If you do, bang those things in. This is a horrible install, like nail wise. This is not super common, but it's pretty common in a house to have at least a couple areas where you'll have a section of tape that has 2 or 3 or 4 little proud areas on it. Maintaining air pressure in your nail gun is tricky.
Yeah, what's the fix of that?
So if I walked out and I saw this, it's already taped, it's not like that, it's like this. First thing I'd tell them is go ahead and bang them all down. There's a couple solutions you could get out of this. You probably have to retape it, almost certainly, actually. There's a bunch of ways to handle that. If it were just 1 or 2, which is the most common, you'll see a couple of them. You'll see like, 8-foot run, you might see 2 or 3 of them. Go in, bang those things flat. Just take a little square of tape, just cut little 4-inch sections off the tape and put it over those areas. Because what'll happen is you're gonna nail metal to metal and it's gonna break through the skin of that.
You're not gonna tear all that off.
Now, you could if you wanted to, you absolutely could remove all the tape.
Try.
You can try. If it's been on there for 2 months in July, good luck. You're gonna pull off the back and you're gonna look, there's gonna be wood fibers with green on it coming with it. And that's it tells you a lot about the strength of the bond when it does get installed correctly. Then when you remove tape, it'll actually take wood flakes off with it when it goes on the edge. It won't do that if you just put it in the middle of the panel, but when you're on the edge and you have all those like a bunch of nails in there, especially if there's a lot more nails that are necessary, you can do that. But yeah, what I would tell people to do is just bang the thing flat and then go back and retape it as necessary. You can put a whole second piece over the whole thing, it wouldn't really matter. You can just layer tape on top of it. Some people, they'll bang it flat, they don't like it. They'll take a wider piece of tape and cover over it. But yeah, most of the time, tell them to bang it flat. So when I look at tape, there's a couple of things I look for that are positives. If I see these, it was rolled enough, and it was rolled using one of our rollers, which is not necessary, but it's not bad. We like it like that. But if you see Z's in it, the little Z's from our imprint from our roller, it was rolled and it was rolled enough. The second thing is, if you were to look at a piece of zip, you'll see this like pizza screen texture to it. And that's because when the mat of flakes with the zip on the bottom goes into the press, it's not going in by itself. It's sitting on this metal pizza screen called platen. And that platen has a little bit of texture. It's a bunch of interwoven metal, very much like a pizza screen. And so when it presses, it leaves it there. And that's total accident. It wasn't designed this way. It's just an artifact of the manufacturing process. Just like the slightly darker color, like the top of an apple pie on the inside of the panel, because it's been heated a lot, so it's like almost burnt look. It's the same thing. With this, if I can see that texture through the tape, you're good. Shiny, smooth, perfectly like black, new car off the lot, shiny. I don't trust that at all. I'll walk up on it, I'll check, I'll make sure it's okay. But if I see the imprint of that zip through the tape, it means it's been pushed on enough that the adhesive has started to work between it, and you're starting to see the peaks of that wood through. Because that means it was rolled enough. If I see fish mouths, which a fish mouth is any crease that terminates on the edge of a panel, not a crease that runs along the seam, those are okay, but a crease that ends on the edge of a panel. That crease is a moisture intrusion point. Any water that's coming down that wall is going to sit there, get caught, and there's a seam right behind there. It's just going to go straight into the wall cavity. It's going to cause all sorts of fun times for everybody. So if I see fish mouths, it probably wasn't rolled to begin with, because it's really easy to roll those out. It's like pretty trivial. Secondly, you got to fix that. You could just cover over that with a piece of tape, another piece of tape. So this area, the rest of this is relatively well adhered. They just didn't roll that side for some reason, or just dirty there. You can just take a piece of tape and cover it. Yeah. You could also remove the tape if you wanted to. You can go in, you can use a knife and cut on the zip. that's acceptable, you don't have to worry about it. I mean, it takes a lot to damage the actual WRB on the panel. But yeah, this kind of stuff just screams, I didn't roll this to me, which is frankly the larger issue. So you can cut it out and then just overlap a piece over the top, and just splice a piece in. That's
So-
perfectly fine.
I think earlier you said that, using, Tyvek tape was not a good idea, but what about going the other way, about using yours on Tyvek?
So if you have a detail, because we run into this a lot in fire rated assemblies, because zip isn't fire rated, and people will use commercial house wrap, specifically Tyvek, which is actually a very good commercial house wrap over the top of like a fire rated, like a gypsum or a flame block type panel. When you have those two edges come together, you see this a lot on commercial structures that are in cities. There'll be a fire rated wall and a non-fire rated wall. And when you have that joint, what you want to do is Tyvek wants you to lap Tyvek over on the zip and then use their tape to take the Tyvek to the zip. We're fine with that, but we then want you to come back over the top of it with our slightly wider tape and tape over that joint the other direction. So you're using two tapes, really, just completely like transparently, Huber doesn't care about the Tyvek tape at all. Tyvek cares about the Tyvek tape, and if you want that system to be covered by Tyvek, use both tapes. If you just want it to work, use the zip tape. Because the zip tape is also an acrylic adhesive, and it is much more acrylic adhesive than the Tyvek tape, like almost 10 times as much acrylic adhesive.
So to that point, you're saying, you're gonna tape over the Tyvek tape. If it doesn't have that much adhesion, what the hell is putting your tape over top of it gonna do?
Yeah, so what's going to happen then is, say this was Tyvek tape, just hypothetically, right? And this was a joint, this was all house wrap, and this was zip. You're gonna have the house wrap come over here, you're gonna Tyvek it. The Tyvek tape is going to keep Tyvek happy. Same thing for Type R or whoever else it was. What you're gonna then do, if this were the edge of the Tyvek tape, is you're gonna take a piece of zip tape and you're gonna cover over it. You're gonna have the zip tape at least an inch onto the zip, and then at least an inch onto the Tyvek tape. You could probably get enough tape to actually get all the way back onto the house wrap, because the Tyvek tape's only, I think, about 1.5 or 2 inches wide, which means you should be able to cover all the way back onto the house wrap if you wanted to. But their tape will stick to their product just fine. So if you tape from the zip over on the Tyvek tape that's on both,
Okay,
then that joint is good. So, and it's double covered. They're saying they're covering it, we're saying we'll cover it, everybody's happy, and they don't care that we're over the top. The reverse isn't really true. They don't like doing that. We don't really care, but they don't like doing that. Oh, there we go. That's a great question, by the way. These are those fish mouths again. In terms of rolling the tape, if you can see these Z's, it was rolled enough. And then not seeing Z's isn't damning all by itself. It's possible to be well rolled and not have Z's. What were you gonna say, brother?
Quick question, saw it known where they got a little carried away with the nail gun. And I don't know why there could have been 25, 30 nails in the area, and they just blew that.
They watched Scarface the night before.
And,
Yeah.
I mean, at that point, there's no barrier anymore, right?
So
What's your opinion? I mean, is it bigger than a fist?
if it looks like somebody just like machine gunned it.
Yeah.
So there's a bunch of problems that pop up. The first one is, I sincerely doubt it was probably over a portal wall, or so like you have like a big portal frame, like a garage header. It was probably either there, is my guess, if you saw it, or it was somewhere in the floor assembly. And they were trying to like hit the ends of
Pull it in or something.
was going on. That's where we see that most commonly. Two things. One, I don't think there's an engineering detail that says what the structural capability of that panel is anymore. And just from a long-term durability, envelope is important. Structure is also really important. So I would be concerned about the structure as well. So that's the first thing I'll say. The second thing is, yeah, it's entirely possible that you could blow off enough of the stuff that you would. The good news is you can tape over it. Like,
But it's bigger than a fist. You were talking about cutting
if
it
you
out.
actually have a gap in the wood, like they Scarface this, they went nuts, and there's actual large chunks of wood missing, like in the panel, then yeah. But if it's just that there's damage to the surface,
Just
and
tape a bigger
just
area.
tape it, just tape over it. But again, I would definitely have someone take a look at that from an engineering perspective and make sure that that's acceptable. There's a reason they're supposed to use a lot of nails and portal framing like applications, but there's also sort of like It's the toilet paper problem, right? You put enough perforations in an area and it's gonna tear if any stress is applied to it. Yes, sir.
So to this point, and you said you ought to have, let the client know they ought to have looked at. So we typically would end up making a note, you need to have manufacturer approved, make sure that this is okay. Do you provide something to the purchaser or the builder that, yes, this repair is acceptable?
So,
How does the homeowner get proof that, something has been
so
approved?
it is a great question, and it illustrates kind of a sticky area for manufacturers in general, right? I think you probably deal with some similar issues, which is there's a difference between being able to point out when problems exist and certifying that there are no problems, right? Because it's possible to miss something or something happened in a way that you didn't fully understand. So what we do when we go out and we look at structures is we do not conduct inspections. We very as reps. Because we have reps that's almost all they do is they do trainings and observations. We go out and we do observations and we are looking for problems and we will call out all the problems. And we'll put together a formal document that says these are all the problems that we saw that we think we should fix. We do not come back afterwards and tell them that everything is just perfect. That is not something we are willing to do. We are willing to say when something is wrong and then it is up to them. Now, that being said, say this structure, no one from Huber had ever heard of it, ever. And it's just, we come across it one day and there's an issue. What will happen is they will go in and look and see if things were done in accordance with manufacturer guidelines at the time of construction. All panels have a date stamp on them, so you can tell when the things were made. And we're usually pretty lenient about if there's a small change in installation around them. Like we're very like customer friendly kind of people, but if it's not installed correctly and the lack of correct install causes a problem, we're not going to pay out on it. And so we want to try and catch as many of those upfront as possible, let them know they exist, but it is on them to fix them and make them correct.
Got it.
So,
Yes, it avoids the warranty if it's not done.
yeah. But that being said, if you had one window that had Tyvek tape on it, and the thing that had a problem was all the way around the house on a completely separate area that was installed in accordance with our installation instructions, we're not going to void the warranty for the whole building because of one detail that was wrong, or even a bunch of details that were wrong that just were not at all related to the issue that popped up.
Sure.
So, yeah, it's definitely something that we care very much about doing the right thing, but there has to be a line somewhere where we can fall back behind that line and say, look, this is reasonable. That we went out, we did our job, we told people what to do. If they don't do it, at that point, it's on them. So.
So what about putting Tyvek over, Jeff?
Yeah, so there's a bunch of reasons you might do that. The probably the most common one is in I guess a couple most common ones. If you have an application where there are some parts of the wall that are house wrapped for other reasons, they were existing wall and they need to be lapped over onto the zip or fire rated. There's a bunch of reasons you might have a wall that needed a house wrap that you couldn't put zip over for some reason. So that's the first one. We talked about that earlier, where you lap the house wrap over onto the zip as a joint treatment, right? You're treating that joint between the two different panel systems. You have two different wall assemblies basically that are joining each other, either fire rated or existent wall that's meeting up with a new zip wall. The second common reason that I would say is you have any directly adhered masonry product. Could be like ephes or stucco kind of product. Could be a directly adhered stone, a mortar adhered stone, not something that has a gap, like a brick wall that will typically have a gap between the back of the brick and the front of the wood panel, right? That allows some kind of drainage to the assembly. But if you have directly adhered, we used to call it lick and stick stone when I was an installer, where it's just mortar's troweled on, there's maybe some screening material there, and it's directly adhered. That area code has required for a while now. I don't remember exactly when it switched, but it requires 2 WRBs. Zip counts as one, it does not count as the second one, so you need something over the surface of that. Now, one other thing that's going to be changing, it's already in code and been adopted in like Gulf states, but not up here, is that those 2 WRBs are going to have to be separated by at least 3/16 of an inch. And the adoption of that will probably be before 2030 sometime. I don't know exactly when. I don't know if it'll even be by 2030, but just in general, it seems like sometime in the next decade or so, that'll have made it more places. There are a lot of places where people who have done stucco walls have had major mold remediation and moisture intrusion issues because they did not correctly detail. And this gap allows a drainage cavity to help mitigate that issue, which is why it's being introduced into code. But if you were to build in southern Alabama or Florida, my understanding is this is code today, that those two WRBs have to be separated. The last reason, I'm sorry, someone had a question?
I was gonna say, is the zip screen, rain screen system that you guys have now qualify as that?
Yeah, it meets that. It's both a WRB and it has an entangled mesh separation system that will separate those two out. It's a great question.
What about a brick veneer that has a gap between the brick veneer and the zip? Do you have to have a separate or?
Not code required. You're allowed to. It doesn't explode, you know, or anything. It's just, it's not required by code that you have a second layer there. At least in most instances. The last instance in which it's a good idea to use a house wrap, any house wrap really, but say Tyvek, over the top of zip is zip has a very long exposure rating relative to most WRB systems. It's basically half a year, but there are jobs where it starts and then there's an issue with the builder or the funding, or there's just a series of permits that have that take a while to show up, and you can end up outside of that 180-day window. We count it from when material hits job site, because it's really the only way to know when construction started is when the bill of lading says that it landed on a job site. So that's when we say it starts. And when that happens, you get 180 days. In some cases, you can, edge cases, you can ask a zip rep and they may come out. And if it's a really good install, you might get like a 30-day extension. So if it's really close, you know, you might get a little bit of wiggle room. But in general, no, it's 180 days, they call it. If you're going to be significantly outside that, or you took over a project and you don't know when it was installed, in order to protect yourself, it might be a good idea to put a second WRB on there. And that would be true for any WRB. If it was a house wrap, Tyvek, Type R, barricade, whatever, right? Anything that was installed on there that was extended on there past the end of its like exposure life cycle, putting a second layer WRB on there is beneficial. And there's not really any issue with permeability or anything like that.
So putting Tyvek or your board doesn't cause a problem.
No, not inherently. I'm sure there's ways to make issues if you really wanted to, but in general, no. So when you think about wall design, you want to put in the wall that is the least permeable, and then things get more permeable going out and in both directions in general. If you're just using what I would call a normal track builder wall design, drywall, 2x6 wall with fiberglass insulation, wood panel, house wrap or zip, and then some kind of siding on the outside. The least vapor permeable thing is actually the latex paint on the inside. So everything can just dry outwards if it needs to. So if you have house wrap on top of it, the zip membrane itself, the wood's about 2 to 3 perms. The zip is like 12 to 16 perms. House wrap tends to be more permeable than that. I believe Tyvek is somewhere in the neighborhood of 20, maybe a little more. And that they're actually, I think, on the lower end of a lot of those. You have those perforated membrane house wraps, they're not very good, really. Then those are, I think, much more permeable than that. So that it doesn't cause a problem from a permeability perspective. You aren't worried about trapping moisture. The biggest issue you run into with house wrap, really, from like a theoretical building science perspective, is it can either help with your air barrier, or it can allow moisture to drain out the bottom of the assembly, but it has a hard time doing both. If you take the bottom of the assembly so it keeps air in when the wall is positively pressurized, or the house is positively pressurized relative to the exterior, then any moisture that condenses out between the house wrap and the structure goes down and sits in like a pond liner at the bottom and causes issues. If you leave that area open, which would allow drainage, you now have lost some of your air retention capability. That means you have to do a lot more inside of the wall in order to keep the air from getting out that far. If you use zip, your air barrier, your WRB layer, your vapor control layer, your structural layer are all one layer. And so you don't have to worry about any of that. You know, if your WRB is intact, your air layer is intact. And so it's a lot easier to manage that. But putting house wrap over the top isn't inherently problematic, because you've probably already done something to manage all the air infiltration there in the zip system anyway. So if you're just out past your exposure rating, say it sat for a year and you need to come back and fix it afterwards, putting house wrap doesn't introduce any particularly large problems.
Have we talked about nails? What particular kinds of nails?
Yeah, we don't have any real guidance on nails outside of code approved fastener. So it's a 60 nail. We recommend 2 inches, in length or more. You need an inch of penetration into the stud. That's the rule. But if it's an R sheathing product, you need 1.5 inches penetration into the stud. So that's really where you run into more issues with fasteners, because most people are pretty familiar with how to frame up a 7/16 OSB wall. That's a very solved problem. People have been doing it for a long time. Almost every house you're going to have bought that's going to have been built in this area, at least anytime in the last decade or two, had some kind of OSB wall on the outside. It was probably 7/16 or 1/2 inch thick. So that's not an issue where people really need to worry. If it was good enough for your regular commodity OSB, it'll work for zip. Now, there's a couple of caveats to that. One is your architect or your engineer may have specified a corrosion resistant fastener, in which case you need to adhere to that. We don't require it. It is not code required in this area. I believe when you get the coastal regions, it can be a little more that you have to do it. But not in the majority of this geography. The other thing with the R sheathing with the longer fasteners is, if you think about like how long that fastener is going to have to be, not only does it have to go farther to the stud, but you now have to travel through the foam as well. So up to about an R6, which is the most commonly used in this area, is R3 or R6. It's a 1/2 inch of foam or an inch of foam. A 3-inch nail, a 2.5 or a 3-inch nail, respectively, will be just fine. And every nail gun I've ever seen, strength framing wise, will handle at least a 3-inch nail. Most will handle a 3.5-inch nail, which would get you out to R9, which is 1.5 inches of foam, 1/2 inch of wood, and then the 1.5 inches into the stud. The problem is if you go to an R12, R12 would require a 4-inch nail. A 4-inch nail is not going to fit in most framing nail guns. They do exist. They're large. They look like instruments of war because they're so big. And they're a pain in the rear end to use. They're hard to find nails for. But it is a solution. We see a lot of people when they go to the R12, they start hand nailing the panels. So
this specific question is about roofing nails.
roofing nails. I don't believe roofing nails are an accepted fastener for wall panel installation. I could be wrong about that. I would invite them to reach out to me offline, and we will figure out what the answer to that question is and what applications roofing nails might be permissible for installation as zip. But I'm not aware of them as being an approved fastener for us, or even an approved fastener for panel installation in general. So, but there may be a detail that I'm not aware of. Interesting question.
We'll talk about the dangers of the paper backing, the tape.
The paper backing on the tape and
Yeah.
pulling it, and the issues of pulling it off.
No, how slippery it is.
Oh, yeah. So I mean, one of the great things about zip on a roof assembly is it's actually fairly high coefficient of friction. It sheds moisture really well. It's not smooth. There's little peaks on it. So it's pretty grippy to walk on. That is not true of the tape. The tape is extremely slippery. Not the tape itself, but like the backing to the tape. It's pissy wax paper. It's pretty glossy. Yeah, don't step on it on a roof. Yeah, remove that. Yeah.
Question. When siding goes over the zip system, the J channels, does the caulking necessary between the J channel and the window frame?
Most siding and window manufacturers are going to tell you that they want it there. I used to work for Hardy. That would have been part of Hardy's installation guidelines, that was the caulk joint. The reason it's a good idea from a WRB perspective is the thing that kills WRBs is typically UV exposure. And so if there is a gap that is large enough that daylight will be hitting that section, it will cause it to break down and fail eventually. And that's what those caulkings are for. They're really to prevent that. It's also a certain amount to keep bulk water out. You know, you think about like the house wrap, the WRB system, zip or house wrap, either one, and the cladding, hardy, vinyl, whatever. It's like clothes and your skin, right? Like you stay outside in the summer all day, you're gonna get beet red and your skin's gonna blister and you're gonna get skin cancer, right? So you wear clothes, right? But the clothes don't keep all the water from getting into the inside of your body. That's your skin's job. So those two things work together. They deal with like the 4 Ds of dealing with water difference, like deflection, drainage, drying, dirt. Like they handle those Ds differently. They work together to help maintain like the integrity of the envelope. So caulking that joint helps keep bulk water out, which means any imperfections in the skin are safe. But it's mostly about protecting it from UV exposure, because that will kill it eventually.
So,
Sorry.
I'm sorry. I see that there's a builder on Pravillia Road. That I've done several of those homes and they just say, it's not required. If I see gaps more than about half an inch around the windows.
Mm.
And.
My understanding is most manufacturers want those caught. Now, we don't have a requirement on it,
Okay,
but we do have a requirement that zip be covered. And so it starts getting large enough, then we would start having an issue with it. But if you can't see any of the WRB or the tape behind it, because there's something else in the way, then I don't think we technically have a problem with
I'm
it.
just concerned water getting there and there's a, they didn't roll the tape under the window.
Yeah.
Trapped.
The good news is, whether people realize it or not, there's water getting behind siding all the time.
Pressure washing, you know?
Yeah, you get a good wind driven rain. I mean, if you listen to someone talk about installation, they'll say they're like, they're installing like a dimensional siding, PVC or Hardy or Boral or whatever. But if you listen to them, you say, what are you doing? And you hand them like a bunch of like Certainty or KP or whoever, any vinyl product. Hey, what are you doing? How do you install a vinyl? Oh, you hang it. Because you don't actually nail it to the wall. It expands enough that you actually have to leave it loose. So it's just hanging on the wall. If you walk over to any vinyl siding on, you can rattle it and the top of it will wiggle back and forth. Because it's not nailed flush. The nail head is not, it's not nail head, vinyl, and wood all smushed together. There's actually wiggle room there, and that's intentional so that it can move. If you look at a vinyl siding top, the top of it where you nail, they're not nail holes, they're nail slots. And it's so that the wall, when it heats up and cools down, the vinyl can actually move along that. And so it's not tight to the wall. And if you get enough wind-driven rain or enough wind blowing behind rain, you are getting moisture behind there. And that's not even including all the stuff the house breathes out, because the house has a certain humidity and temperature year round, and the outside changes. And so the way that those pressures affect the wall assembly, you can get moisture that the house has breathed out into that wall assembly that needs to be dealt with, let alone whether it's raining. So there's lots of stuff going on.
So I've seen the zip used for wall assemblies and for roof sheathing. Can it be used for, say, these, the 4th story roof deck meant for foot traffic?
It's a great question. No. It sure is the short answer. We require some kind of sloped roof. That would be a flat roof application. We have other products that get used there fairly frequently. So we have like subfloor panels. If most people are familiar with Advantech, we have a mid-range product as well. And there's a really high-end Advantech that got launched maybe like 3 years ago called X Factor. It's got a gold colored, very similar to zip overlay on top of a regular sheet of Advantech. You can use those there. But if you think about what's going on there, the rubberized roofing membrane that is in that situation is handling almost all the heavy lifting, and it's meant to be exposed from UV. They do tend to have a higher failure rate than just an average sloped roof, mostly because water can sit there for longer. But there's not a huge benefit to installing a WRB beneath that surface.
So what's the
usually.
minimum slope?
The minimum slope for zip, I believe, is 4, unless you have a second layer of WRB, in which case I believe we're allowed down to 2. But code would require any surface that is below a 412 pitch to have 2. It's not technically a WRB, it's like just a felt, it's a roofing felt. Yeah, or you can use an ice and water. That's the other way you can get around in a lower slope roofs, is you can use an ice and water. And we have an ice and water as well. So, but yeah, below 2, I know we're out. I believe we can go down to 2, but it requires a second layer of WRB to go with it, or a second felt layer. These are great questions. I love the detail of these questions.
Yeah, this is stuff that once the house is built, we don't see it.
Yeah, all of our products are very, like, nothing's a finish. Nothing we make is a finish. Everything's meant to be hidden. But the thing is about this, like, if you think about when you frame out a house, as soon as you put house wrap on it, it's gift wrap. You have no idea what's beneath that, really. The benefit of zip is after you've installed the panels and taped all the joints, you can still see the problems. So you can address the problems. You know when there's a hole in the wall. they could let air out because you can see it. It's not hidden behind Christmas paper. You know, it's not gift wrapped. It's there for you to see. So you see all these issues that you're looking at as you go through this. We've talked about most of these. Oh, this is another one. If you see cleats on a roof, or if they're masonry, they'll put cleats on a wall so they can string masonry lines. They're gonna pull those off. Those are gonna be penetrations through a wall. So one of the things we'll see people do is if they're coming out doing inspections while the house is still under construction and not clad, spray paint those, like the ones on the wall, maybe not the ones on the roof unless you're getting up there, but you know, those masonry cleats on it, spray paint those areas. And if you come back and there's no tape inside of that spray paint, there was a problem there. So another thing that'll happen is people will miss studs. I'm sorry, I'm trying to be conscious of everyone's time here, but people will miss studs. Those are gonna get banged out by the insulator, almost assuredly. Then you end up with holes. So the good idea to walk the framer at least, or you know, if you're doing a bunch of inspections, one of the things it's good to do before you get installation is walk the inside. Because looking from the outside in, it can actually be pretty hard to see a hole sometimes, especially if there's not a lot of like buckling or deformation of the panel around the hole. You really got to know it's there. And sometimes you'll think that there's just a fastener in it. If you look from the inside out, it is extremely obvious. It looks like someone shot a bullet through the wall. There's like a big old daylight. Just looking in, it's black. And you don't pick out those kinds of shadow details the same way you pick out a light point. But if you're inside on a normal day, even if it's overcast, but there's just a reasonable amount of ambient light, and you're looking around, you can pick out the daylights all over the place. It's super easy. Also, if you're walking the inside, you'll see if someone missed a whole stud or missed a lot of a stud. And again, two issues, right? First issue is there's no fasteners there, so it's not doing any structural work. And the second one is you now have a bunch of potential infiltration points for water. And it's both of those problems simultaneously. This is the same detail we saw earlier. Okay, not okay. So up to about halfway through, we're not worried about it. We're not. It's going to have a structural problem before it's going to have it. So if you're doing a Montgomery County or any of the counties that have a framing inspection, if the framing inspector passed it and didn't have any issues, you're probably not going to have that many over. You probably don't have that many overdriven fasteners. It's still worth looking at, but it's just a good indicator. People are like, oh, the entire wall, every single fastener needs to be taped. We go, okay, how did your framing inspection go? Oh, we thought it looked great. You probably have some you got to tape, sure, but probably not the entire wall. This is just what that repair looks like. Little square tape, done. Here's your Scarface detail you were talking about earlier. Someone just went bananas. There's no engineering detail for the load carrying for that section of wall. You might seriously think about just removing it and replacing it with a new piece and then taping those in. Deal with these big holes, anything that's bigger than a fist. Definitely the best way to deal with this thing at the top, they have them just cut out the top section to begin with. It's so much easier. But just cut out a section, block it, and then put in a new piece. A lot of this is going to be redundant from what we just went through, so I'm just going to scroll through it real quick. Oh, one other thing we see a fair amount of, you don't want, whether it was us or Tyvek or Typar or whoever, none of the WRB manufacturers want brick walls terminated back to them. So there's a gap here, right? If you were to look, there's a gap here. There's a gap here, but they got to the end of that brick wall and they're like, we want to return it. So they return it all the way back to the house wrap. Unless there's two layers there, you can't do that. It will be a failure point at some point in the future. And this is pretty common, especially if you have houses where it's like I used to call them lean-to. You have like the front of the house is brick and the rest of it's wrapped in plastic siding. They'll come around the sides a little bit, they'll wrap it around the sides. So you're looking at the front of the house from the street, it looks like it's really expensive. And you walk around to the back and you can't tell the difference between a $1.5 million house and a $400,000 house. But when they do that, there's usually an area where they have to terminate the bricks back. And keeping an eye on this is not bad because this is more common than most people realize. And it usually takes place in between, not inspections, but our observations. We'll see when windows are in and we might see later on, but we aren't going to be here when this is going on usually.
Brick tiles, they be taped.
So you don't have to tape. You don't have to. We don't require it. It's also very difficult to tape metal strapping that has multiple fasteners through it. It'd probably be a little easier to apply like a fluid applied to it, just because it'll get in all the nooks and crannies really easily. The biggest issue we have with brick ties when they're used with zip R sheathing. Because zip R is wood panel and stud, and there's a void in the middle. And the brick ties are supposed to go back, but you can with regular zip, just install the brick tie straight over the zip, nail through it, and you're fine. It's the same thing for all the fasteners for the cladding, right? You're gonna install fiber cement or, vinyl siding, you're gonna put tons of holes in that. But all those holes are gonna have a fastener in them, and so they're not a problem.
So liquid flash and fluid applied are synonymous terms?
For me, yes, I apologize, I should have clarified that earlier, but yes, I use our fluid applied liquid flash system, it's sort of like how one of those two ways how I refer to it, but yeah. We talked about this in the last presentation as well, having these joints taped is a really good idea. My favorite detail for this is you tape the joint first. Then you install whatever flashings you have, and then you tape over the top of the flashings. The number of things that have to fail going down that are significant. Another good detail here is if you have an ice and water shield, run the ice and water shield up onto the wall as well. Tape the uphill side of the ice and water shield if you're going to do that. You're just creating layers, because this is one of these places, as a former roofer and siding guy, this is one of those places where you have like leak issues all the time. First 4 issues I had with the zip install where someone said, my zip's not working, come out and take a look at it. The first 4 of them were all this detail. And they were all house wrap tapes instead of zip tape from the roofing installer. But this is one of those areas where there's a lot of bulk water moving, and if it's not done correctly, and you also have 2 different installers, your roofer is very seldom the same guy doing your siding. And usually that person, neither of those people are the framer. And so you have 3 people working together in that area, and all of them have to have done it correctly, or there's a water entry. But they blame the roofer. When you have these sort of bolted on, either like a deck ledger, or you have like a bolted on porch roof, it's very common for them to frame out the house and then bolt a deck roof on after the fact, even with trusses. You want to do a tape beforehand. Now, is it ever going to leak up in here? Ever? No, not really. I mean, the roof would have had to have failed. You'd have way bigger issues if that happened. But it's part of the air barrier, and you want the air barrier to be intact for indoor air quality, for making your blower door test scores, just for energy efficiency reasons. And so taping the entire zip wall and then bolting all of these sort of vestigial framing things on the outside is a really good idea. It's definitely an area I see new builders miss on, is they think, oh, this is just the WRB, so I don't even do it in there. I mean, it's just structural panel behind there. Doesn't really matter if it's WRB. It doesn't have to be WRB, but it is the air barrier. The air barrier does need to be continuous. This detail was in the last slide presentation. That's the end of this one, really. It's taking the uphill side of it. I have taken you guys past 9 o'clock. You'll have had some fantastic questions. I really enjoyed this. I'm gonna put my phone number back up again for a second in case anyone wants to take pictures of it. I'm on the website. I don't mind being called about asked random questions. I don't mind being asked to come out and take a look at jobs. If it's not me, we have a technical manager that covers a pretty good area as well. One of the 2 of us will show up. But
Send you pictures.
send me pictures. You're like, hey, what do you think about this? And I'll give you as much guidance as I can based off of pictures, or if I need to show up, I'll show up. So, showing up versus answering pictures is usually a big of a lag time, but
Most of the time it's fish mouth, creases, peeling edges, and all that stuff that says it hasn't been rolled.
yeah.
And I just want to send a picture and have. I'm mostly interested in the tag at the bottom that says you work for Zip. That says, no, that's not right, and that's
Yeah,
all I need.
Yeah, and we'll say that, like, I don't like the way that looks. It doesn't look like it was rolled effectively, or, that there's something missing in that detail. Yeah, that's easy for us. The thing we will not tell you is, especially in writing on an email without ever having looked at a job, is, oh, that looks fantastic. The best you're ever gonna is, I do not see any immediate issues just from these pictures. There's something along where there's like a lot of edging. Because we don't want to say it looks perfect, and then we show up later and they're like, there's a wall missing, and like, why didn't you see the wall missing? So yeah,
I couldn't see the wall missing because it wasn't there.
it wasn't there, it wasn't in the picture. So it'd be like, based on the pictures you have sent, these areas do not present any immediate concerns. For a field inspection would be advisable, something along those lines. So
Thanks very much.
Thank you.